In ancient times, humans would huddle around the flickering light of a campfire, wondering what might lurk out in the darkness. And in that respect, things haven't really changed. Our campfires are larger now. Our vision reaches across the globe and out to the very edges of the observable universe, thanks to instruments like the James Webb Space Telescope. And yet, there's always an edge where the darkness falls, and it's left to our imaginations to fill in what lies beyond. The truth is there's mounting evidence to suggest the boundary of our sight is not the end of reality. And what hides in that final dark may rewrite everything we know about the universe and our place in it. When we talk about the edge of the universe, it's easy to picture a physical wall at the end of everything. But the reality is far stranger. The boundary we can't see past isn't a wall, but a horizon in time. It's what we call the observable universe. The concept is tied to the ultimate speed limit, the speed of light. Because the universe began roughly 13.8 billion years ago with the Big Bang, we can only see light from objects that has had enough time to reach us. But here's a puzzle. While the universe is 13.8 billion years old, the observable part is about 93 billion light years across. How can it be so much larger than its age suggests? The answer lies in a fundamental property of our cosmos. It's expanding. To get your head around this, imagine the universe is a balloon being inflated. If you draw two dots on its surface, the dots themselves aren't moving across the rubber, but the space between them is stretching. This is what's happening in our universe. Space-time itself is expanding. The light from the most distant galaxies has been traveling for nearly 13.8 billion years. But in that time, the space it was crossing has continued to stretch, pushing its starting point much farther away from us. So the edge of our observable universe isn't the end of space. It's a horizon of information. It is widely, almost universally believed that there's more universe beyond this limit. It's simply the point where space is expanding away from us so fast that light leaving from there today will never reach us. We've lost the ability to interact. The question is, what does that unseen cosmos look like? The simplest and perhaps most humbling possibility is that the universe is infinite. In this model, what lies beyond our horizon is simply more of the same. An endless expanse of space with an infinite number of galaxies, stars, and planets, all following the same laws of physics we see here. This idea comes from our best measurements of the cosmic microwave background, the afterglow of the Big Bang. So far, all our observations show that the universe on the largest scales is geometrically flat. According to our best theories, a flat universe is an infinite one. No edge, no boundary, just an eternal continuation of space and time. If this is true, then everything we see, every galaxy, every supercluster, is just a tiny patch in an unending cosmic sea. Out there, every possibility could be realized. There might be other galaxies identical to our Milky Way, other stars identical to our Sun, and perhaps other planets identical to Earth, where other versions of you are living out lives with the smallest of differences. It's a staggering thought. Our entire observable reality could be nothing more than a single grain of sand on an infinite beach. But what if there are clues, even within our own cosmic bubble, that hint at something more complex? The James Webb Space Telescope has been peering back to the cosmic dawn, and what it's finding is starting to challenge our models of the early universe. Astronomers have found galaxies that are far more massive, bright, and chemically mature than they should be for their time. For instance, JWST has spotted galaxies like JADE's GS Z14-0, which we see as it was only 290 million years after the Big Bang. The problem is they look nothing like what our theories predicted. The early universe was supposed to be a much darker, simpler place. These galaxies are like brilliant lighthouses shining where we expected only dim candlelight. This suggests that the processes of star and galaxy formation happened much faster than our models allow. It's as if the universe had a hidden head start. Scientists are debating the cause. Perhaps these galaxies contain the very first generation of stars, or they're powered by early supermassive black holes. Whatever it is, these discoveries are a profound signal that something might be missing from our understanding. And if our theories can't fully account for what's happening at the edge of our own visible space, it forces us to ask what other, even bigger surprises are hiding just beyond it. This is where the theories become truly mind-bending. One of the most compelling ideas to emerge from modern cosmology is that our universe isn't alone. It may be just one bubble in a vast frothing sea of other universes, the multiverse. This isn't just science fiction. It's a potential consequence of a theory called eternal inflation. The idea is that the Big Bang wasn't a one-time event. Instead, the rapid expansion of space, known as inflation, could be happening all the time, constantly spawning new bubble universes. Like bubbles forming in boiling water, new universes pop into existence, each potentially with its own unique laws of physics. One might have stronger gravity, another might have different particles, another might not have light at all. In this model, our Big Bang was simply the moment our bubble came into being. We are forever isolated within our own cosmic patch, unaware of the countless other realities that might exist alongside ours. Some physicists propose that what lies beyond isn't more space, but more dimensions. Stemming from string theory, the brainswirl hypothesis suggests our entire 3D universe could be a flat membrane or brain floating in a higher dimensional space called the bulk. What we perceive as an edge might just be the limit of our three-dimensional perception. Other models do away with a single beginning altogether. Cyclic theories propose an endless series of big bangs and big crunches, with our universe being just the latest in an infinite chain of cosmic reincarnations. Then there's the holographic principle. This idea suggests our three-dimensional reality could be a projection, a hologram of information stored on a two-dimensional surface at the boundary of our universe. In this scenario, what's beyond the edge wouldn't just be an extension of our reality. It would be the very source of it. These ideas may sound like wild speculation, but scientists are actively searching for evidence. They're meticulously studying the cosmic microwave background, looking for anomalies, cold spots, or strange patterns that could be the bruise left by a collision with another bubble universe in the distant past. And our tools are getting more powerful. NASA's Nancy Grace Roman Space Telescope, set to launch by May 2027, will have a field of view hundreds of times wider than Hubble. It will map the large-scale structure of the cosmos with unprecedented speed, surveying millions of galaxies. By creating this vast cosmic tapestry, Roman could help us test these fundamental theories about the universe's geometry and the mysterious dark energy that's accelerating its expansion. We are like cosmic detectives piecing together the nature of a reality far larger than what we can directly see. So what is hiding beyond the edge of the universe? The answer could be an infinite sea of more galaxies, much like our own. It could be a multiverse of countless other worlds. Or it could be a higher reality our minds can barely conceive. For now, the edge of our universe remains the ultimate boundary, a veil separating the known from the truly unknown. But the quest to understand what lies beyond is what drives cosmology forward. It reminds us that everything we have ever known might be just one chapter in a much larger story. With every new discovery, the darkness simply retreats a little further, revealing the next cosmic boundary and causing us to wonder once more. There is always more to know, and humanity's hunger for that knowledge will never cease. If our own cosmic backyard is full of these shocking surprises, what do you think is hiding in the great unknown? Let us know your wildest theories in the comments below. And if you're enjoying this journey into the cosmos, make sure you subscribe so you don't miss our next deep dive into reality's biggest questions.